Welcome everyone to the first week of our PHP web development course. This is not a typical PHP course. We're going to learn PHP by building something real and meaningful. Over the next 14 weeks, we will progressively build a complete greenhouse gas reporting and accounting platform called CarbonTrack. Today we'll start by understanding why we're building the domain of carbon accounting, and then dive into the first two chapters of PHP. By the end of today, you'll understand what GHG reporting is, you'll have PHP running on your machine, and you'll be writing your first emission calculations in PHP. Let me give you the roadmap. Every week we learn new PHP concepts from the textbook, and we immediately apply them to our semester project. By week 5, you'll have a command line emission calculator. By week 8, it becomes a web application with login. By week 12, it's a fully object-oriented system. And by week 14, it's connected to a database with complete create, read, update, and delete operations. The key idea is progressive development. The project grows with your skills. You might wonder, why GHG reporting? Why not build a shopping cart or a blog? Because carbon accounting is one of the fastest growing software markets in the world right now. The European Union's CSRD directive requires roughly 50,000 companies to report their greenhouse gas emissions starting 2024. The US SEC has proposed similar rules. Turkey, as an EU candidate country, is aligning with these regulations. This means every mid to large company will need software to track, calculate, and report their emissions. What we're building is not academic. It's a real product that companies actually need. Let's start with the science. Greenhouse gases are gases in our atmosphere that absorb and re-emit infrared radiation, essentially trapping heat. The main ones are carbon dioxide from burning fossil fuels, methane from agriculture and natural gas systems, and nitrous oxide from fertilizers. There are also synthetic gases like HFCs used in refrigeration. Now, greenhouse gases are natural and necessary. Without them, Earth would be frozen. The problem is that human activities have dramatically increased their concentration. CO2 levels are now over 420 parts per million, the highest in at least 800,000 years. This is what drives climate change, and this is what we need to measure and report. Here's a critical concept for our platform. Different gases have different warming potentials. 1 kilogram of methane traps 28 times more heat than 1 kilogram of CO2 over a 100-year period. Nitrous oxide is 265 times more potent, and sulfur hexafluoride, used in electrical equipment, is a staggering 23,500 times more potent. To make these comparable, we convert everything to CO2 equivalent, or CO2e. This is a simple multiplication, the mass of gas times its GWP. In our platform, every emission entry will be stored in kilograms of CO2e. This is the universal unit of carbon accounting. The GHG protocol is the standard for carbon accounting. Think of it like GAAP or IFRS, but for emissions. It was developed jointly by the World Resources Institute and the World Business Council for Sustainable Development. Almost every major company in the world uses it. When we build our platform, we'll follow GHG protocol methodology for categorizing emissions, applying emission factors, and generating reports. If you learn this framework, you understand how carbon accounting works everywhere. Let's break down the 3 scopes. Scope 1 is the most straightforward. These are direct emissions from sources the company owns or controls. If your company has a boiler that burns natural gas, those combustion emissions are Scope 1. If your company owns a fleet of trucks, the diesel they burn is Scope 1. If your air conditioning system leaks refrigerant, that's Scope 1 fugitive emissions. The key test is, does the company own or control the source? If yes, it's Scope 1. In our platform, we'll track each of these categories separately because they require different emission factors and calculation methods. Scope 2 covers indirect emissions from energy you purchase. When your office uses electricity, the emissions happen at the power plant, not at your building. But because you're the consumer driving that demand, you're responsible for reporting those emissions. There are 2 ways to calculate Scope 2. Location-based uses the average emission factor for your regional grid. For Turkey, that's about 0.47 kilograms CO2e per kilowatt hour. Market-based allows you to use specific factors from your energy supplier or account for renewable energy certificates. Our platform will support both methods. Scope 2 is often the largest emission source for office-based companies. Scope 3 is where it gets complex and interesting. These are all the other indirect emissions in your value chain, both upstream and downstream. The GHG protocol defines 15 categories, from purchased goods and services to business travel to the end-of-life treatment of your products. Here's the shocking part. For most companies, Scope 3 represents 70 to 90% of their total carbon footprint. But it's also the hardest to measure, because you depend on data from suppliers, customers, and third parties. In our platform, we'll start with the easier Scope 3 categories, like business travel and employee commuting, and build up from there. This diagram shows how the three scopes relate. Your company is in the center. Scope 1 is what happens inside your fence line, your boilers, vehicles, and processes. Scope 2 is the energy flowing into your company, electricity, steam, heating. And Scope 3 wraps around everything else, your suppliers upstream, your customers downstream, your employees commuting, your business travel. A complete carbon footprint covers all three scopes. Our platform will handle all of them. Keep this mental model as we build the system. Emission factors are the heart of carbon accounting. They're essentially conversion rates. You multiply your activity data by the appropriate emission factor to get emissions. If you burned 1,000 liters of diesel, you multiply by 2.68 to get 2,680 kilograms CO2e. These factors come from scientific organizations and government agencies, the IPCC, the UK's DEFRA, the US EPA, the International Energy Agency. Different sources may have slightly different factors. Our platform will store a database of emission factors and automatically apply them when users enter activity data. This is exactly the kind of calculation PHP is good at. Let me walk you through a real calculation. Imagine a factory with a natural gas boiler. First, we identify it as an emission source and classify it as Scope 1 stationary combustion. Then we collect the activity data, how much natural gas was consumed. Say it's 15,000 cubic meters in Q1. We look up the emission factor, 2.02 kilograms CO2e per cubic meter. Multiply 30,300 kilograms CO2e. Divide by 1,000 to get tons, 30.3 tons. We record this for the Q1 2025 reporting period. Then a manager verifies the entry. This entire workflow is what our CarbonTrack platform will automate. Every step maps to a feature we'll build. In carbon accounting, time matters. Companies report emissions for specific periods, usually annually for official disclosures, and quarterly for internal tracking. In our platform, we'll use a format like 2025 Q1 for quarterly periods. This lets us aggregate and compare over time. Companies also need to define their organizational boundary, which entities and operations are included. And they set a base year as a reference point. For example, a company might commit to reducing emissions 42% below 2020 levels by 2030. The base year lets them track progress. In our database, we'll store the company's base year and calculate reductions against it. This is what a simplified GHG report looks like. And this is exactly what our platform will generate. You can see the three scopes broken down by category, with totals for each scope and a grand total at the bottom. There's also a comparison against the base year, showing a 12.4% reduction. By week 14, our CarbonTrack platform will generate reports like this automatically from the data users enter. It will pull from the database, aggregate by scope and period, and output a formatted report. This is the end goal. Keep this picture in mind. Let me show you the data architecture of our platform. Users enter activity data through web forms. How many liters of diesel? How many kilowatt hours of electricity? The system validates this data, looks up the appropriate emission factor, and calculates CO2e. This gets stored in the database. From there, the data flows two ways, to a real-time dashboard showing current emissions, and to a report generator that can produce formal GHG inventory reports. We'll also support CSV export for integration with other systems. Over 14 weeks, we'll build every piece of this pipeline. These are the 7 core entities of our platform. A company is the organization. Users belong to companies and have roles, admin, manager, or reporter. Emission sources are the specific things that produce emissions. A boiler, a fleet, electricity consumption. Emission factors are the scientific conversion rates. Emission entries are the actual data points users create. Reports aggregate entries into formal summaries, and the audit log tracks every change for accountability. Each of these will become a database table and a PHP class. Today we'll start working with these concepts using simple variables. Our platform has 3 user roles with different permissions. Reporters are the frontline data collectors. They create emission entries, edit their drafts, and submit them for review. Managers can do everything reporters can, plus they can verify or reject submitted entries and generate reports. Admins have full access, including user management and system configuration. Notice the entry lifecycle at the bottom. An entry starts as a draft, gets submitted for review, then either verified or rejected. Rejected entries go back to draft for correction. This workflow ensures data quality, which is critical in carbon accounting because these numbers may be audited. Let me briefly cover why this market is exploding. The EU's CSRD requires around 50,000 companies to report sustainability data starting 2024, including GHG emissions. The Carbon Border Adjustment Mechanism will impose carbon taxes on imports starting 2026. The US SEC has proposed similar disclosure rules. The ISSB has created global standards, and Turkey has its own monitoring, reporting, and verification regulation for large industrial emitters. The result? A massive demand for GHG reporting software. Companies like Watershed, Persephone, and Sphera are valued at billions of dollars. What we're building in this course is a simplified version of these commercial platforms. Here's a useful analogy. Carbon accounting mirrors financial accounting in many ways. Instead of tracking money, you're tracking carbon. Your chart of accounts is replaced by scope categories. Transaction entries become emission entries. Invoices become utility bills and fuel receipts. The trial balance becomes your emission inventory. Financial statements become GHG reports. And just like financial audits, GHG reports undergo third-party verification. Even the standard setting is parallel. GAAP and IFRS for finance, GHG protocol for carbon. If you understand one, the other makes sense. Our platform is essentially an accounting system where the currency is CO2 equivalent. Let's recap what we've covered. You now understand what greenhouse gases are, how they're measured using GWP, and how the GHG protocol organizes emissions into 3 scopes. You know the basic calculation formula, activity data times emission factor. You understand reporting periods and base years, and you've seen the architecture of the platform we'll build. This domain knowledge is crucial. You can't build a good tool without understanding what it does. Now let's shift gears and learn our first PHP. By the end of this hour, you'll be writing emission calculations in PHP code. PHP is one of the most widely used programming languages in the world. It powers roughly 77% of all websites where the server-side language is known. WordPress, which runs about 40% of all websites, is built in PHP. Facebook started in PHP. Wikipedia runs on PHP. It's been around since 1995, and PHP 8 brought modern features like named arguments, enums, match expressions, and strong typing. Some people dismiss PHP as old, but PHP 8 is a modern, performant language with excellent features. For web applications like our GHG platform, it's an excellent choice. You have 2 options for running PHP. The textbook covers Replit, which is a browser-based coding environment. No installation required. This is convenient for getting started quickly. However, for our semester project, I recommend installing PHP locally. On Mac OS, use Homebrew. On Linux, use apt. On Windows, download from php.net or install XAMPP, which bundles PHP, MySQL, and Apache. Once installed, you can run any PHP script from the terminal with php filename.php. For web development, PHP has a built-in development server you start with php-s localhost 8000. Let's make sure everyone has PHP working before we continue. Let's write our first PHP program. Every PHP script starts with the opening tag, but in pure PHP files, files that contain only PHP code, no HTML, it's actually recommended to leave out the closing tag. We'll discuss why later. The echo statement outputs text. Every statement ends with a semicolon. Forget it and you'll get a syntax error. The \n inside double quotes creates a new line. Save this as hello.php and run it with php hello.php from your terminal. If you see the output, PHP is working correctly. PHP was originally designed to be embedded in HTML. Anything outside the PHP tags is treated as template text. It's sent directly to the browser as is. The PHP code between the tags gets executed on the server, and only the result is sent to the browser. So the browser never sees. It only sees something like 2025-09-15. This is fundamental to understanding server-side programming. The server processes the PHP, generates HTML, and sends that HTML to the client. Later in the course, we'll use a proper templating engine called Twig, but for now, this embedding approach helps you understand how PHP works with HTML. Comments are text that PHP ignores. They're for humans reading the code. You have three styles: // for single-line comments, hash for single line, and /* for multi-line blocks. Most PHP developers use //. A good comment explains why you're doing something, not what. Don't write increment counter by 1, that's obvious. Instead write add GWP adjustment for methane. For our GHG platform, comments will be especially important because we're dealing with domain-specific calculations that aren't obvious to every developer. Always comment your emission factor sources and calculation methodology. Variables in PHP always start with a $sign. This is one of PHP's distinctive features. You can always spot a variable immediately. Variables are case sensitive, so $name and $name are different variables. You can store any type of data in a variable: text, numbers, booleans, null. Notice in the echo statement when you use double quotes, PHP will automatically replace variable names with their values. This is called string interpolation. We'll cover this in more detail next week. For our platform, we'll use meaningful variable names that reflect the GHG domain: $emission factor, $kudu kilograms, $reporting period. Variable naming is more important than you think. In a GHG platform, clarity is critical because calculations affect regulatory compliance. Don't use single letters or vague names. Use names that tell you what the data represents and, ideally, the unit. I recommend adding the unit to the name when it matters. $C code 11 kilograms versus $C code 11 tons. This prevents unit confusion errors. Use camel case consistently, and stick to domain terminology: $in activity data, $in emission factor, $in reporting period. These are GHG protocol terms that any carbon accountant would recognize. Good naming is free documentation. Chunks are like variables that can never change once defined. In carbon accounting, GWP values are scientific constants. CO2 is always 1, methane is always 28, nitrous oxide is always 265. These should be constants, not variables, because accidentally changing a GWP would corrupt all your calculations. There are two ways to define constants: define and const. The const keyword is preferred in modern PHP for class-level constants. Notice that constants don't use the $sign, and by convention, they're named in all scores. We'll use constants extensively for emission factors, unit conversions, and configuration values. PHP supports all the standard arithmetic operators. For our GHG platform, multiplication and division are the most important. Multiplication for calculating emissions from activity data, and division for converting between units like kilograms to tons. The modulus operator gives the remainder after division, useful for things like determining which quarter a month falls in. Exponentiation uses the double star operator. The order of operations follows standard math rules: multiplication and division before addition and subtraction. Use parentheses to make your intent explicit, especially in complex GWP calculations. That last example calculates total GWP from a mix of 3 gases. When you're building up a total, like adding emissions from multiple sources, the combined assignment operator, plus equals, is much cleaner than writing out the full addition each time. This pattern is extremely common in our platform. Iterate through emission sources, calculate each one, and accumulate the total. The plus equals operator adds the right side to the existing value and stores the result. Similarly, minus equals subtracts, plus equals multiplies, and minus equals divides. The increment operator plus plus adds 1, and minus subtracts 1. These are useful for counting entries, tracking iterations, and similar tasks. Let's put it all together with a real emission calculation. We define our GWP constants, set up company info and variables, and then calculate Scope 1 emissions from a natural gas boiler. The calculation is simple: usage times emission factor. We echo the result showing the formula and the answer. Notice how we can embed variables directly in double-quoted strings, and how we use the concatenation operator, the dot, to combine strings with expressions. This is the foundation of our platform. Every feature we add over 14 weeks builds on this basic pattern of taking activity data, applying a factor, and producing CO2e. Now let's calculate all three scopes. For Scope 1, we have a natural gas boiler and diesel vehicles. For Scope 2, purchased electricity. For Scope 3, air travel and rail travel. Each source gets multiplied by its emission factor, and we sum within each scope. Then we add all three scopes for the grand total. Notice how parentheses keep the arithmetic clear. This is essentially what our platform does at the core level, but instead of hard-coded values, it reads from forms and databases. I want you to type this in and run it. Change the numbers. See how the totals change. Get comfortable with the pattern. When you output numbers in a report, formatting matters. Nobody wants to see 30300.00000. They want 30,300.00. PHP's number format function handles this. The first argument is the number, the second is decimal places. Optional third and fourth arguments let you change the decimal separator and thousand separator, useful for European formatting where a comma is the decimal separator. For our GHG reports, we'll typically use 2 decimal places for kilogram values and 1 for tons. Notice how we divide by 1,000 and format in the same expression. Clean, professional output is part of what makes our platform useful. There are multiple ways to build strings in PHP. The dot operator concatenates joins 2 strings together. The operator appends to an existing string, which is great for building up multi-line output like reports. In double-quoted strings, you can put variable names directly inside, and PHP will replace them with their values. This is called interpolation. It doesn't work with single quotes. For our platform, we'll use all 3 approaches in different contexts. Concatenation assignment is especially useful when building formatted text output line by line, as shown in the box drawing example. Take 10 minutes to write this script. Define your constants and variables, do the calculations, and produce formatted output. For the percentage contribution, divide each source's emissions by the total Scope 1 and multiply by 100. This is a realistic exercise. Every company with physical operations needs exactly this calculation. I'll walk around and help if you're stuck. When you're done, compare your total with your neighbors to make sure you get the same answer. Here's the solution. The total Scope 1 comes to 70,722 kilograms, or 70.72 tons CO2e. The boiler is the largest contributor at about 42.8%, followed by the fleet at 39.2%. These percentages are valuable. They tell the company where to focus their reduction efforts. If they want to cut Scope 1 emissions, targeting the boiler and fleet gives the best bang for the buck. This is the kind of insight our platform will provide automatically. Notice the clean formatting, aligned columns, consistent decimal places, percentages in parentheses. Professional output matters. Before we move on, let's make sure your PHP is configured properly. The php.ini file controls PHP's behavior. During development, you want display errors turned on and error reporting set to EALL, so you see every warning and notice. Set your time zone to your local time zone. For us, that's Europe/Istanbul. You can check your PHP version with PHPV from the terminal. The PHP info function generates a complete page of configuration details, useful for debugging but never expose it on a production server. Run php ini to find where your configuration file is located. Let me save you hours of debugging by showing you the most common PHP mistakes. Number 1, forgetting the semicolon. Every statement must end with a semicolon. Number 2, forgetting the dollar sign on variables. Number 3, using a single equal sign in conditions. This assigns instead of comparing. This is a classic bug that's hard to spot. Number 4, using a variable that was never defined. PHP will give a warning, not an error, which can lead to subtle bugs. Number 5, case sensitivity. Dollar emissions and emissions are completely different variables. And number 6, division by zero. Always check that your divisor isn't zero, especially when calculating averages or percentages. PHP has 4 basic data types called scalar types, meaning they hold a single value. Integers are whole numbers useful for IDs, counts, and years. Floats are decimal numbers essential for emission values, percentages, and emission factors. Strings hold text, source names, scopes, reporting periods. And Booleans are either true or false, perfect for flags like, is this entry verified? Then there's null, which represents the absence of a value, like when an entry doesn't have any nodes. Later in the course, we'll learn about arrays for collections and objects for complex data structures. For now, let's understand these basic types deeply. Integers are whole numbers, no decimal point. In our platform, we'll use integers for database IDs, user counts, years, and similar whole number values. PHP integers on a 64-bit system can hold values up to about 9.2 quintillion, so we'll never run out of range for our purposes. The var dump function is your debugging best friend. It shows both the type and value of a variable. GetType returns just the type name as a string. One important note, when you divide 2 integers and the result would be a decimal, PHP automatically converts it to a float. So 7 divided by 2 gives you 3.5, not 3. Floats are decimal numbers, and they're absolutely critical for our platform. Every emission factor, every calculated CO2e value, every percentage is a float. But there's a trap you must understand. Floating point precision. Computers store decimals in binary, and 0.1 plus 0.2 does not equal exactly 0.3 in floating point arithmetic. The result is 0.3000000000004. This means you should never compare floats with equals equals. Instead, check if the difference is smaller than a tiny threshold. For our platform, we'll round values appropriately for display and use proper comparison techniques. This isn't a PHP problem, it affects every programming language. Strings are text values enclosed in quotes. Single quotes are literal, what you see is what you get. Double quotes allow variable interpolation. PHP replaces $ and variable with its value inside double quotes. In our GHG platform, strings appear everywhere. Source names, scope labels, reporting periods, units, statuses, categories. The strlen function returns the length. Str checks if a string contains a substring useful for search functionality, and substr extracts part of a string. We'll use this to parse reporting periods, extracting the year and quarter separately. We'll cover strings in much more depth in week 2. Booleans have only 2 possible values, true and false. They're perfect for flags and conditions. In our platform, we'll have many Boolean checks. Is this entry verified? Is this source active? Is the user an admin? Can this status transition to another status? Comparison operators like greater than, less than, and equals produce Boolean results. So $CO2e tons 100 evaluates to either true or false, and you can store that result in a variable. This makes your code more readable if isHighEmitter is clearer than if CO2e tons 100 when you use it multiple times. Null is a special type that means no value. It's different from 0 or an empty string. 0 is a number it has a value. An empty string is a string it just happens to be empty. Null means no value has been assigned at all. In our platform, many fields are optional notes, subcategory, rejection reason. When a user doesn't fill in the notes field, we store null, not an empty string. The distinction matters for database operations and display logic. Use is null or strict comparison null to check for null. The isSet function returns false for null variables, which is a handy quick check. PHP provides a family of is functions to check variable types. These are crucial for our platform because data coming from web forms is always a string, even if the user typed a number. Is-numeric is especially important. It checks whether a string could be interpreted as a number. When someone enters 15,000 in an emission data form, it arrives as a string. Is-numeric 15,000 returns true, telling us it's safe to use in calculations. But is-numeric 12,500 returns false because of the comma. We'll use these functions heavily in our validation layer to ensure data integrity before calculating emissions. PHP is a loosely typed language, meaning it automatically converts between types when needed. This is called type juggling. If you multiply a string by a float, PHP converts the string to a number first. If you concatenate a number with a string, PHP converts the number to a string. This is convenient but can lead to bugs. The Boolean conversions are especially tricky. 0, empty string, null, and empty array are all falsy. But watch out, the string 0 is also false, while the string 0.0 is true. These edge cases matter when validating form data. My advice, use explicit checks rather than relying on type juggling. Check is numeric instead of just seeing if a value is truthy. This is one of the most important slides today. PHP has two kinds of equality, loose with double equals and strict with triple equals. Loose comparison converts types before comparing, which leads to surprising results. 0 equals empty string, 0 equals null, empty string equals null. These are all true with loose comparison, and they can cause real bugs. In our platform, if someone enters 0 as an emission value, loose comparison with false would incorrectly treat it as no value entered. Always use strict comparison in your code. It checks both the type and the value. This is a best practice that will prevent countless bugs. Typecasting lets you explicitly convert between types. Put the target type in parentheses before the value. Int, float, string, bool. This is important for our platform because form data always arrives as strings. When we need to calculate with it, we cast a float. Float, post activity data. When we need a database ID, we cast to int. Int, post, source ID. Be careful with int on decimals. It truncates, it doesn't round. Use round when you want mathematical rounding. One warning, int 42abc gives you 42, silently dropping the non-numeric part. Always validate before casting. Let me map our platform's data to PHP types. Every field has a natural type. IDs and years are integers. Emission values, factors, and percentages are floats. Names, scopes, periods, and statuses are strings. Active verified flags are booleans, and optional fields are nullable. When we build our database in weeks 13-14, these PHP types will map to SQL types: int, decimal, varchar, tiny int, and nullable columns. When we build classes in week 9, these become typed properties. Understanding the right type for each piece of data is fundamental to building a robust platform. This example ties everything together: constants, floats, arithmetic, and formatted output. We're calculating the total global warming potential from 3 different greenhouse gases. Notice the insight at the bottom. Methane is only 0.6% of the total mass, but because of its GWP of 28, it contributes 17% of the warming impact. This is exactly the kind of analysis our platform will provide, helping companies understand not just their total emissions, but which gases and sources matter most. The code uses all the concepts from today: constants for GWP values, floats for measurements, arithmetic for calculations, and number format for clean output. Var dump is the most useful debugging tool in PHP. Unlike echo, which just shows the value, var dump shows the type and value. This is crucial when hunting bugs. Is your variable a string 0 or integer 0? Is it null or an empty string? Var dump tells you immediately. In the example, notice that multiplying 2 strings gives a float result. PHP's type juggling at work. Var dump reveals this. When we get to web development, wrap var dump in tags for readable output. Get in the habit of using var dump whenever something isn't working as expected. It's not elegant, but it's effective. I want to give you a preview of something powerful. Modern PHP supports type declarations. You can specify what types a function accepts and returns, and PHP will enforce them. This means if someone passes a string where a float is expected, PHP will throw an error instead of silently doing the wrong thing. This is incredibly valuable for a platform where calculation accuracy matters. We'll cover this in detail in week 3 when we learn about functions. For now, just know that PHP can be as strict about types as you want it to be. Our platform will use type declarations throughout to prevent bugs. Let me formally introduce your semester project. CarbonTrack will be a fully functional GHG reporting and accounting platform. By week 14, it will have user authentication with 3 roles: a registry of emission sources, data entry forms with validation, automatic emission calculations, a status workflow for quality control, a dashboard with summary statistics, report generation, audit logging, and CSV import-export. Each week you'll add a new layer based on that week's PHP concepts. The project is cumulative. Each week builds on the previous week's. Don't worry if this sounds overwhelming right now. We'll take it one step at a time. For your project setup this week, create a CarbonTrack folder. Inside it, create a Week 01 subfolder. Each week you'll add a new subfolder. This week you'll create 3 PHP files. Emissionsbasics.php covers basic variable and constant usage with emission calculations. GWPcalculator.php implements the GWP calculation we just saw. And ScopeCalculator.php calculates all 3 scopes for a hypothetical company. Over the coming weeks, these scripts will evolve into a web application with forms, databases, and objects. But it all starts here, with simple PHP scripts that calculate emissions. Here's your homework. Create a complete emission calculator for a fictional company. You have multiple sources across all 3 scopes. For Scope 1, note that you have 3 trucks and 5 cars. You'll need to multiply the per vehicle consumption by the count. For Scope 3 employee commuting, you need to chain several multiplications. Employees times daily distance times workdays times emission factor. Your output should be a formatted report showing each source, each scope subtotal, the grand total, and the percentage contribution of each scope. Use constants for GWP values and conversion factors. Use number format for all displayed values. Your output should look professional, like this template. Each source is listed with its calculated emissions. Scope subtotals are shown in both kilogram and tons. The grand total is at the bottom with scope percentages. This format mirrors what a real GHG report looks like, and what our platform will eventually generate automatically. Pay attention to alignment and formatting. Use number format consistently. The goal isn't just getting the right numbers, it's presenting them clearly. This is due before next week's class. For resources, the official PHP manual at php.net is comprehensive and well organized. Bookmark it. The GHG Protocol website has free standards documents if you want to understand the methodology deeper. And for emission factors, DEFRA publishes an excellent annual spreadsheet of conversion factors. Next week, we'll cover strings in depth, including functions for searching, extracting, and manipulating text, and conditionals, which let our code make decisions. We'll use these to build an emission source classifier that automatically determines the scope and severity based on input data. It's going to be a big step toward making our platform intelligent. Let's wrap up. Today we covered a lot of ground. We started with the carbon accounting domain. You now understand what GHG reporting is, why it matters, and how emissions are calculated. Then we learned PHP fundamentals, variables, constants, operators, and output formatting. And we finished with data types and introduced the semester project. You have the tools to write your first real emission calculation scripts. The homework will reinforce everything we covered. Start early and don't hesitate to ask questions. Remember, every professional feature of our CarbonTrack platform starts from these basics. Next week, we'll learn strings and conditionals, and our emission calculations will start making intelligent decisions. Great first class. See you next week.